Okay, so on this problem, we are subtracting two fractions. And the crucial issue, what is probably the most common mistake in algebra, is forgetting to distribute. Remember, this minus sign needs to go boom, boom, and boom. Distribute the minus sign. And the reason for that is because we're subtracting the whole second fraction, not just the front part. The common mistake is to put the minus only on the front part, but that's just clearly not what this means, right? We're subtracting the entire second fraction. Now, you also might wonder, why doesn't it go to the bottom? Well, that minus sign goes only to the top or only to the bottom, but not both, right? Think about a minus in front of a fraction. If you have minus 4 over 2, you can put that minus in the top only or put that minus in the bottom only, but not both. Why not both? What if you put the minus on both? That would actually make it back to positive, wouldn't it? That makes sense? All of these are -2, really. All of these really equal -2. So they're all the same. So when you have a minus and that's in the front, you can put it in the top only or the bottom only, but not both. If you put it in both, you've made it back to positive. You've negated it. You've made it do nothing, really. So, and now you're saying you could put it in the bottom? You could, but I don't want to, because that would make the bottoms different. I don't want the bottoms to be different. That would be a big pain. So we're not going to put it in the bottom. So we're going to put it in the top only. Top only. You could do top or bottom, but not both. I'm going to do top. So, all right. So then what happens when we do that? Well, the bottom stays the same. We don't do anything with the bottom, right? You know that. I always do the candy bar analogy. 1/4 and 2/4 is 3/4, right? Real life candy bar, right? 1/4 and 2/4 is 3/4 of the candy bar. You don't add the ball. You don't say 3/8, right? That's just not what it is. It's not true. It's 3/4. All right. So you don't add the bottoms, right? That's just what's true. Okay. So now what about tops? What happens up there on the tops? Well, let me bring the first one over. It's going to be 9x squared minus 5x minus 5. And then I'm going to do the second one with the distribution. So it's going to be minus 7x squared, right? That minus sign puts 7x squared. And then minus a minus 5 is going to make it plus 5x. Did you see that? And then minus 5. Spin that bar a little bit. There we go. Right? We good there? And now let's combine like terms. This guy and this guy. (9x squared minus 7x squared is 2x squared. And minus 5x and plus 5x cancel. And minus 5 and minus 5 is minus 10. Interesting. Got a little smaller than I expected. Are we good to there? Do we see what has happened so far? Let me pause. Let you digest this for a minute. You see all this action? So 9x squared minus 7x squared, 2x squared. Right? And the minus 5x and the plus 5x cancel. And the minus 5 and the minus 5 made minus 10. Okay, now are we done? No, we need to reduce. Now reduce. Okay, so I just cancel the x squared, so 5 goes into 10 2 times. No, you know better than that, huh? Why can't we do that? You cannot cancel added, subtracted items. So instead factor. That's how we get around that problem, right? We factor. Okay. So how am I going to factor? In the top, I can take out a 2, can't I? See, these guys both have 2 in common. Leaves x squared minus 5. That's awfully convenient. Right? You with me? Right, that 2 can distribute, can't it? Go back to 2x squared minus 10. And now we're in business. Cancel multiplied items. So now this, you might think, well, this bottom is still subtracted. Well, it's really multiply. Let's back it up here. It's really multiplied by 1 if you want. So these guys cancel. They're multiplied items. And so that ends up with 2/1, and that's just 2, right? So our final answer to this problem is just 2. Boy, this big old original with these big old fractions, it all reduced down to just 2. And you know about that, right? We never leave ones in the bottom. We leave ones in the top. If you have a 1 on the top, you leave, but you never leave ones. But why? Because 2 divided by 1 is just 2, right? Right. 1 goes into 2 times, so it's just 2. So there we go. A lot of reduction on that one.